Hey, Donovan Keith here, and in this video I want to talk about how you can create your own custom nodes distributions or advanced distributions from the cloner object using scene nodes. So here I've recreated something called the Phyllotaxis, I guess effect is what I'm going to call it, but basically it is a property of flower petals and the little bits on pine cones that they sort of arrange themselves in kind of this spiraling pattern where each spiral is offset in just such a way that they don't ever create super neat rows or lines or patterns, and it gives you this nice, very organic feel. And it's just a little bit of math to get us there, and I think it'll be a good way of exploring how to create your own custom distribution, and then you can go off and make other more interesting or more complex forms. So just to give you a preview of what the setup looks like, I've got a cloner. Inside of my cloner, I've got a single flower petal, which I stole from another flower. We might not recreate this in the video. And then I've got an advanced distribution on my cloner, which is pointing to this distribution here. And if I turn my cloner back on, you can see that we can adjust the count. I can adjust phi, so that's that Phyllotaxis angle, right? You see, if it's not that very special 137.5, it doesn't really look like a flower anymore. So it's a very specific angle. And then here we can adjust the amount of sort of tilt in or out. And I can adjust an inner radius. I can adjust an outer radius. And I'm sure we can create more controls than that. And just to show you another sort of distribution that you could make, this is a really simple circle distribution, and it's automatically adjusting the radius of the circle based on the size of the piece and the gap size and the circle radius. So you always get a nice, very specific looking collection of elements. And just to show you the node setup for this one, there's a little bit of complexity here. A lot of these are just your user inputs. On the other, as we take a look at the node setup, it's a handful of nodes that gets you there. If you don't want to, go through all the complexity of creating your own node setup, there's a ton of great advanced distributions that you can play with. Most of these were created by Rocket Lasso, and you can just browse in here and get something like a Canonball distribution, which would allow you to, for example, take a sphere and stack it in a really cool way. So these distributions can get really powerful, and if you're curious about how this is set up, you can go in here and choose Edit Asset as Group, and you can begin to see the complexity of a setup like this. Now, actually not as complex as some of these scene node setups get. So how do we create this Phyllotaxis effect? Well, let's go ahead and create a new project file, and let's go ahead and just add a sphere as the simplest shape. And to make our lives a little bit easier, I'm going to make the total width of this sphere 1, and so that means that the radius needs to be 0.5. And I'm just going to tap H to frame that up a bit. So now this is my base shape. I'm going to put it inside of a cloner. Fun trick is if you hold down the Option key and add your cloner, it gets added as a parent. If I tap H, we'll see we've got a grid, but we can't see it very well because of all of these very small spheres. I'm going to go to my Advanced tab, and I'm going to choose to create my own custom node setup. And I'm just going to go ahead and modify my layout here to nodes, move this over here, click on my distribution. And what we can see here is that the final output of this group is something called a container. And a container is a collection of arrays, and an array is a list of a kind of a thing. So we've got a sort of a basket full of lists of things, and the most important list of things inside of this container is the list of matrices or matrices. And this list of matrices controls the position of every single clone that you're creating. So if I was to come in here, double click and choose Build Array, and I can change the element type here to matrix and connect this to the output, we see that we get a clone. I can come in and adjust the second one. Now, granted, this is really small, I can adjust the scale. The third one, I could move it over here and up and adjust the scale. And that's really all that we're doing as we are building our own custom distribution, is we're building a list of arrays, or excuse me, we're building a list of matrices or transformations of an object in space. And these transformations are what get applied to your clone. So if I was to come in here and add like a cube that's 1 by 1 by 1, we can see that that's now the shape that's going in here because we haven't specified the clone type. If we go to our main cloner, we could choose to not take the clones from distribution, and then it would automatically pick another shape for us in a row. The color here hasn't been set yet, all those things. So I'm just going to go back to having my single sphere. I'm going to get rid of this build array, and we're going to figure out how to build our own array from scratch. And my favorite way to do that, we're going to use it in almost every tutorial, like I've got a tutorial on how to build a line, is to start with what's called a range node. So I'm going to double click and choose range, and this just counts up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. In fact, it counts up to whatever this end number is. Right now that's 0. So I'm going to add another port by double clicking, typing IO for input output, and count. I'm going to wire in that count here. And so now if I click on my distribution, we see that we've got a count input. I can crank that up. And now this is just going 1, 2, 3, 4, 5, 6, 7, 8. If I try and connect my range to my matrix, I can't. And that's because a counting number is not the same thing as a transformation. So what I want to do is somehow transform my range here into a matrix. So I'm going to use something called a symbol collection. And a symbol collection lets me create something of a given type. So I'm going to click on this matrix right here, right click on this and choose copy type. In my symbol collection, I am going to I think there might even be a down arrow here where I could choose to edit the data type and paste this in, choose OK, or I can come in here, choose add input, data type, select it, and choose to paste the value being the type that we copied. So now this thing is trying to build an array of matrices. This input value here takes a translation, a rotation, a scale, and also this little sort of brackety thing. And this I think is called a scope. And it basically says, all right, these counting numbers that we're starting up here, we want to turn them into something over here. What we're going to turn them into, we need to specify. So I'm just going to take my translation, open it up, take my range, these are my counting numbers, and I'm going to plug that into X and plug the result into matrix. And now I have got a series of clones that match my count exactly. And you're like, wow, they're lining up so neatly. Well, that's because I got the radius right? Each of them is 1 wide, and they increase by a value of 1. You can right click on this and choose data inspector and see that that's what's happening. They're just sort of counting up. So our trick here, the thing that we have to do, is figure out how to translate this increase in position into a rotation of some sort. So we have to figure out how to rotate these step after step after step. And I'm going to do that in a couple of ways. We are going to actually, let's just use point on circle, which is I think a little bit easier to understand. Point on circle. So the point on circle node takes in a given radius, and it takes in a ratio. So how far we are is 0 to 1, and it sort of transforms it. So I can take my range here, so that's 1, 2, 3, 4, 5, and my count, and if I was to divide those, that would give me a ratio. Or I could, let's go with an angle as an input, and I'm going to control click on this dot right here to expose my angle. And now if I, let's say, put my position here, I can use my range as my radius, let's say. We're not really seeing much. I can put my range excuse me, I want to connect this whole position right here, and my count, I don't know, it could be angle or something like that. So this isn't really doing anything that makes any sense. So what we need to do is modify this angle based on the current number here. So I'm going to adjust the radius and the angle. And the angle, I'm going to choose to scale my range, which you can kind of think of as multiply, by an angle. So I'm going to type in IO angle, so I can bring in a simple user interface, angle, connect these up, multiply this out, and right now the angle is 0. As I increase this angle, you see that we get something that looks like this. And I can set this to 137.5, and we'll start to get this distribution that makes a little bit more sense. And if I come over here to my setup, I'm just going to kind of cheat and figure out what I did over here. I had an inner radius and an outer radius that I'm sort of mixing between for all of this spinning. So let's do that. Let's give ourselves a control for the outer radius. How wide we want this to get at the outside. So I want to figure out what percentage of these, how far are we through this count, and I want to translate that to an outer radius. I'm going to add an IO size. Let's call this outer radius. And I'm just going to do a simple division between range and count to get my ratio. Now this is an approximation. Theoretically, I would want to subtract 1 from my count so that you get an exact 0 to 100%. Here it's not going to ever quite hit 100%. I'm going to just duplicate the scale node. I'm going to take my ratio, scale that by the outer radius, and that's going to become the radius of my point on my circle. Now, this is even less circly than our last one. Well, let's just reduce our outer radius, and you get something like this, which is where it starts to get interesting. If you really increase your count, for example, it starts to get quite interesting indeed. So you can adjust your inner radius, your outer radius. If we want to adjust the inner radius here, let's just add another IO size. I'm going to move this above outer and call this inner radius. And we're going to do the same thing. I'm just going to copy this scale, hold down Shift to maintain the connection, connect my inner radius. And now I actually want to, rather than scale, I want to mix between these two different values based on my 0 to 100% ratio. So I'm going to add a mix. And I'm going to set this ratio as my blend. Inner radius is going to be the start, outer radius is the end, and now that's the radius for my circle. So now, as I click on my distribution, I've got this inner radius, which is a bit too tall. I've got an outer radius I can adjust. I can adjust my inner radius. I get something like this. I can also, if I want, add in a multiplier on scale. So I could have a start scale and an end scale if I want to control that as well. But this is more or less the setup. Let's adjust the plane of our circle. So right now, point on circle is on XY. I'm going to set it to XZ. So I get something like this. And let's try and put some petals in here. So I'm going to take my my disk, let's say. I'm going to make it -Z. And let's scale it down. I'm going to make it editable and just grab my polygons here, move them up, maybe scale them in a bit, and I don't know, I might regret using a disk instead of a plane, but I can do something like grab a magnet, Shift-C magnet, and I'm just going to sort of pull these back like so. And here we are, we've got a little leaf. I'm going to put that in my cloner. So now they are all cloning in the same pattern, but they're not rotated as we need, and they're also all black. So how do we get them to rotate as we would expect? Well, point on circle, the angle right here, we can try that as our rotation on Y. And it's a start, but we might need to add a small value here. Maybe I'll go with fewer clones to start. So it's looking like adding (1.8), so pi divided by 2. So minus pi over 2, looks like. Gets me a good starting angle. And now we can come in here, we can adjust our inner radius maybe down to 0, our outer radius out like so. We can increase our count, but we also probably want to increase that maximum and minimum angle. So I'm going to add in 2 angle inputs, IO angle. Let's call this min angle. Do another IO angle. Let's call this max angle. We're going to copy this mix, Command Shift to copy with our inputs, min angle, max angle. And let's just do that for our pitch. And it looks like I might want to negate these angles, just because I don't want to have to use negative values. And now I need to also create some colors that look a bit better. So I can do another assemble collection, so just Command Shift right here. I'm going to change the type from matrix array to basic color. And I'm going to choose white. We can just plug that into our color here, and now we've got a white flower. If I want, I could use this ratio to define the color. And now we've got this sort of gradient from inner to outer. And if I wanted to explicitly make that a gradient, I could choose a basic gradient. Put that in there for position, plug that into my color. And let's choose something like Pinkster here. That's kind of nice. Let me see if I can invert the gradient. Get rid of this guy. I think I want it darker right at the very center. And now we've created a very simple, I'm going to call it Phyllotaxis distribution. So again, I can adjust my count. I can adjust my angle, which I probably just shouldn't adjust. I can adjust my radii, my inner radius, the minimum angle for my rotation, the maximum angle for my rotation. And that is a custom distribution that if you were to save, you could reuse in other projects. But for now, I'm just going to keep it right here. And that's there's a lot of ways to make a thing like this. I arrived at, I think, a pretty similar and also pretty different solution here. Again, this sort of circle distribution, yet another way that you can approach something like this. the world is kind of your oyster here. Feel free to play around with the spline mapper to really vary the shape of the positioning here. You could, for example, also adjust the height of this at the top versus the bottom, and that's how you can get one of those sort of more pine cone effects. Plenty to play with. I hope that this was informative about how to create your own custom advanced distributions for MoGraph using C nodes.